ನಮಸ್ಕಾರ ಎಲ್ರಿಗೂ. Welcome to the session 5 of transistors and MOSFETs under the unit 2 of analog electronics. So ಈ session 5 ನಲ್ಲಿ we are learning about the following topics, that is the first topic being different transistor configurations. ಸೊ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅಂದ್ರೆ ಏನು, ಎಷ್ಟು ವಿಧವಾಗಿ ನಾವು ಟ್ರಾನ್ಸಿಸ್ಟರ್ನ ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಬಹುದು ಅಂತ ನಾವು ಹೋಗ್ತೀವಿ. ಅದೇ ತರ ಆ ಪ್ರತಿಯೊಂದು ಕಾನ್ಫಿಗರೇಷನ್ಗೂ ಏನೇನ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಇದೆ ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ತಿಳ್ಕೊತೀವಿ. ಅದೇ ತರ ಕರೆಂಟ್ ಆಂಪ್ಲಿಫಿಕೇಶನ್ ಫ್ಯಾಕ್ಟರ್ ಅಂದ್ರೆ ಏನು, ಸೊ ಕರೆಂಟ್ ಆಂಪ್ಲಿಫಿಕೇಶನ್ ಫ್ಯಾಕ್ಟರ್ ಆಲ್ಫಾ ಅಂಡ್ ಬೀಟಾ and the relationship between alpha and beta. So these are the topics covered in this session. So let's start with the first topic, that is transistor configurations. As we all know, transistor, it has three terminals: the emitter, base and the collector. So if a transistor has to be connected in a circuit, for the input section we require two terminals, and for the output section we require two terminals. But as we have only three terminals in a transistor, we make one of the terminals as common both to input as well as the output section. ಅಂತ ಹೇಳಿದ್ರೆ ಟ್ರಾನ್ಸಿಸ್ಟರ್ನ ಯಾವ್ದಾದ್ರು ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಮಧ್ಯದಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಇರೋ ಮೂರು ಟರ್ಮಿನಲ್ ನಲ್ಲಿ, ಅಂದ್ರೆ ಎಮಿಟರ್, ಬೇಸ್ ಮತ್ತೆ ಕಲೆಕ್ಟರ್ ಇರೋ ಈ ಮೂರು ಟರ್ಮಿನಲ್ ನಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಒಂದು ಟರ್ಮಿನಲ್ ನ ಇನ್ಪುಟ್ ಸೆಕ್ಷನ್ ಮತ್ತೆ ಔಟ್ಪುಟ್ ಸೆಕ್ಷನ್ ಎರಡಕ್ಕೂ ಕಾಮನ್ ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇದನ್ನ ನಾವು ಈ ಕನೆಕ್ಷನ್ಸ್ ಅನ್ನ, ಈ ಕನೆಕ್ಟಿವಿಟಿನ ನಾವು ಕಾನ್ಫಿಗರೇಷನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ನಮ್ಮ ಹತ್ರ ಮೂರು ಟರ್ಮಿನಲ್ಸ್ ಇದೆ. ಸೊ ಅಕಾರ್ಡಿಂಗ್ಲಿ ವಿ ಹ್ಯಾವ್ ತ್ರೀ ಡಿಫ್ರೆಂಟ್ types of configuration, ಅಥವಾ transistor can be connected in three ways. ಒಂದು ಕಾಮನ್ ಬೇಸ್ ಕಾನ್ಫಿಗರೇಷನ್. ಕಾಮನ್ ಬೇಸ್ ಕಾನ್ಫಿಗರೇಷನ್ ನಲ್ಲಿ ಬೇಸ್ ಟರ್ಮಿನಲ್ ನ we keep it common for both input as well as output sections. Second one is common emitter configuration. ಹೆಸರೇ ಹೇಳೋ ಹಾಗೆ ಎಮಿಟರ್ ಟರ್ಮಿನಲ್ ನ ನಾವು ಕಾಮನ್ ಆಗಿ ಇಟ್ಕೊಳ್ತಾ ಇದೀವಿ. Similarly, we have common collector configuration, where the collector terminal is used as common in both input as well as output section. Now we will see each configuration one by one. So in the picture, as you can notice, we have the common base configuration both for the NPN transistor. Here in this case, NPN transistor is connected in common base configuration. Here the PNP transistor is connected in common base configuration. So this is your emitter base junction, which is the input section across which you are applying a signal to be amplified, and this is your output section, that is collector base junction, across which you are obtaining the amplified signal, that is you are obtaining output across the collector base junction. So base terminal is used as common both to the input as well as to the output section. So in this configuration, definitely we can say that IE is the input current and IC is the output current in both the type of transistors, whether it is NPN or PNP. Emitter current is the input current and collector current is the output current. So let us have an equation for current amplification factor for the common base configuration. What is this current amplification factor? See, transistor, it is mainly used as an amplifier. We know this very well. So amplifier na ನಾವು ಯಾವ ತರ ರೇಟ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ the ability to strengthen a weak signal. So ಎಷ್ಟು ಮಟ್ಟಿಗೆ weak signal ನ ಅದು strengthen ಮಾಡ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ನಾವು ಆಂಪ್ಲಿಫೈಯರ್ ನ ರೇಟ್ ಮಾಡುವಾಗ we use a term called gain. So gain ಅಂತ ಹೇಳಿದ್ರೆ ಒಂದು ಆಂಪ್ಲಿಫೈಯರು ಇನ್ಪುಟ್ ಸಿಗ್ನಲ್ ನ ಎಷ್ಟು ಮಟ್ಟಿಗೆ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿ ಔಟ್ಪುಟ್ ಅಲ್ಲಿ ಕೊಡ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ನಾವು ಗೇನ್ ಮೂಲಕ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಗೇನ್, ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಕರೆಂಟ್ ಗೇನ್ or voltage gain, or it can be power gain. ಸೊ ಇನ್ಪುಟ್ನಲ್ಲಿ ನೀವೇನು ಸಿಗ್ನಲ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅದು ಎಷ್ಟರ ಮಟ್ಟಿಗೆ ಆಂಪ್ಲಿಫೈ ಆಗಿ ಔಟ್ಪುಟ್ ಅಲ್ಲಿ ಸಿಗ್ತಾ ಇದೆ ಅದನ್ನ ನಾವು ಗೇನ್ ಮೂಲಕ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಆಸ್ ಅ ಸೆಡ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಐದರ್ ವೋಲ್ಟೇಜ್ ಗೇನ್, ಕರೆಂಟ್ ಗೇನ್ ಆರ್ ಪವರ್ ಗೇನ್. ಸೊ ಕರೆಂಟ್ ಆಂಪ್ಲಿಫಿಕೇಶನ್ ಫ್ಯಾಕ್ಟರ್ ಅಂತ ಹೇಳಿದ್ರೆ ಇನ್ಪುಟ್ ಅಲ್ಲಿರೋ ಬರ್ತಾ ಇರೋ ಕರೆಂಟ್ ಎಷ್ಟರ ಮಟ್ಟಿಗೆ ಆಂಪ್ಲಿಫೈಡ್ ಆಗಿ ಔಟ್ಪುಟ್ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅಂತ. ಸೊ ಆಬ್ವಿಯಸ್ಲಿ ಕರೆಂಟ್ ಆಂಪ್ಲಿಫಿಕೇಶನ್ ಫ್ಯಾಕ್ಟರ್ಗೆ ನಾವೇನಂತ ಹೇಳ್ಬೋದು, ಇಟ್ ಇಸ್ ದ ರೇಷಿಯೋ ಆಫ್ ಚೇಂಜ್ ಇನ್ ಕಲೆಕ್ಟರ್ ಕರೆಂಟ್ ಟು ದ ಚೇಂಜ್ ಇನ್ ಎಮಿಟರ್ ಕರೆಂಟ್. ಚೇಂಜ್ ಇನ್ ಅಂತ ಯಾಕೆ ನಾವು ಹೇಳ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಇಲ್ಲಿ ನಾವು AC ಸಿಗ್ನಲ್ ನ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ವಿ ನೋ ದಟ್ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಸಿಗ್ನಲ್ ಇಸ್ ಅ continuously varying signal with respect to time, and hence we are using word called change. So current amplification factor anta helidre it is nothing but the change in collector current which is the output current and to the change in input current which is the emitter current in case of a common base configuration. Let's look into the figure once again. As you can see here, emitter current is the input current whereas collector current is the output current. So in general current amplification factor anta helidre it is nothing but the ratio of output current to the input current. So in general current amplification factor it is the ratio of output current to the input current. In case of a common base configuration, collector current is the output current and emitter current is the input current, and hence we have this expression alpha is equal to delta IC divided by delta IE. Here the symbol delta is used to indicate that this is a change in current, andre the current which is changing. So alpha is equal to delta IC, that is output current, to delta IE, that is input current. And we know that collector current is almost equal to emitter current alva. Collector current it is almost equal to emitter current. So hagagi alpha value it is always less than unity. It is always less than unity. So practical values of ranges usually from 0.9 to 0.99. Please note that current amplification factor is unitless. It is unitless because delta IC it is in the milliamperes range. Delta IE is also in the amperes. Unit of current is amperes. So both the units ampere cancels out each other and hence we are left with unitless factor. So current amplification factor is unitless andre adike yavude unit illa. So as I said, collector current and emitter current they are almost equal to each other. Hence alpha value it is always less than unity. Usual range being 0.9 to 0.99. So let's look into the application of collector base connection. As we have seen, the current amplification it is less than unity, means that it doesn't provide much current amplification. So hence it is very seldom, rarely used. It still provides voltage gain but without current gain. They are sometimes used as impedance matching circuit in high frequency applications. So high frequency applications nalli navu idanna use ಮಾಡ್ತೀವಿ. Also it can be used to increase output impedance of current sources to increase gain. Current gain ಅನ್ನ increase ಮಾಡೋದಕ್ಕೋಸ್ಕರ current sources ಅಲ್ಲಿ output impedance ಅನ್ನ increase ಮಾಡೋದಕ್ಕೆ ನಾವು ಈ common base connection ಅನ್ನ use ಮಾಡ್ತೀವಿ. Otherwise this circuit is very seldom used ಅಥವಾ rarely used. So the next configuration is common emitter configuration, which is also widely used configuration. Let me come again. Common emitter configuration is most frequently widely used configuration because of many advantages. We will look into those advantages one by one. Okay. In this case, as we all know, emitter terminal is made common to both input as well as output of the transistor. So this is the NPN transistor CE configuration, and this is the PNP transistor common emitter configuration. As you can see here, the emitter terminal is made common to both input as well as the output section. So this is your input section and this is your output section. So current IB, that is base current, is the input current, whereas collector current is the output current. In both the cases, NPN or PNP, base current is the input current and collector current is the output current in case of a common emitter connection. So again, let's have an expression for the current amplification factor beta. So in case of a common base configuration, we use the word alpha to specify the current amplification factor. Similarly, in case of a common emitter configuration, beta is the term used to indicate the current amplification factor. As I said earlier, current amplification is nothing but the ratio of output current to the input current. In case of common emitter configuration, which is the output current and which is the input current? Output current is the collector current and base current is the input current. Let's have a look once again. So we can see here collector current is the output current, whereas base current is the input current. So accordingly, we have an equation for beta, that is delta IC, that is change in output current to the change in input current, which is the base current. As we know that when compared to collector current, IB is very small. So base current is very small when compared to collector current, and hence beta value turns out to be quite large. So beta value ಜಾಸ್ತಿ ಇರುತ್ತೆ. So usual beta values, it is greater than 20 and it ranges between 20 to 500. Practical transistor to beta values 20 ಇಂದ 500 range ತನಕ ಇರುತ್ತೆ. So it is generally greater than 20 because we know that collector current is quite large when compared to the base current. So let's look into the applications of common emitter configuration. As I said, this connection is widely used for many reasons because they are well suited for voltage amplification at low frequencies. So low frequency applications nalli they are well suited and they are also used in radio frequency circuits. They provide both current and voltage gain. So ಹಾಗಾಗಿ ಎಲ್ಲಿ ನಮಗೆ voltage as well as current gain ಎರಡರದ್ದು requirement ಇರುತ್ತೆ ಅಂತ situation ನಲ್ಲಿ common emitter configuration is the best configuration as they provide very good current and voltage gain. So let's look into the last configuration, that is common collector configuration. As the name itself implies that collector terminal is made common for both the input as well as the output section. Collector terminal is made common to both the input as well as the output section. So ಈ ಸಂದರ್ಭದಲ್ಲಿ current IB base current is the input current and the output current being emitter current. So emitter current is the output current and base current is the input current. Input is applied between emitter and the base and the output is taken across the emitter and the collector. So again, let's have current amplification factor for common collector configuration. So in this case, current amplification factor for common collector configuration, it is gamma is used to indicate that current amplification factor for common collector configuration. So same thing here, it is the ratio of change in output current to the change in input current in common collector configuration, emitter current is the output current and base current is the input current. So we have an expression for gamma here. Gamma is given by change in output current, that is emitter current, to the change in base current, that is the input current. So we know that the current emitter current is quite large when compared to the base current, hence they provide a good current gain, but the voltage gain in common collector configuration is less than 1. Hence they don't provide voltage gain, they only provide current gain. Hence even this configuration is very rarely used. So it can be used as a voltage buffer. Voltage buffer anta helidre it is a circuit used athwa inserted between two circuits. Because suppose you have one circuit and one more circuit, in between it acts like a mediator. So idradu impedance ಮತ್ತೆ ಅದ್ರದ್ದು impedance ಎರಡನ್ನು ಮ್ಯಾಚ್ ಮಾಡಿಕೊಂಡು ಸಿಗ್ನಲ್ ಅನ್ನು ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಲಿಕ್ಕೆ intermediate ತರ use ಮಾಡೋ circuit is your voltage buffer circuit. So common collector configuration is used as a voltage buffer. It can also be used in the, it is also used in the output stages of class B and class AB amplifiers. Analog electronics to 4th unit ಅಲ್ಲಿ ನೀವು amplifiers ಮತ್ತೆ types of amplifiers ಬಗ್ಗೆ detail ಆಗಿ ಓದ್ತೀರಾ. ಸೊ ಅದರಲ್ಲಿ ಕ್ಲಾಸ್ ಬಿ ಕ್ಲಾಸ್ ಎ ಬಿ ಆಂಪ್ಲಿಫೈಯರ್ಸ್ ಬಗ್ಗೆನೂ ಓದ್ತೀರಾ. ನಮ್ಮ ಕಾಮನ್ ಕಲೆಕ್ಟರ್ ಕಾನ್ಫಿಗರೇಷನ್ ಸರ್ಕ್ಯೂಟ್ ಅನ್ನ ನಾವು ಈ ಆಂಪ್ಲಿಫೈಯರ್ಸ್ ಔಟ್ಪುಟ್ ಸ್ಟೇಜಸ್ ನಲ್ಲಿ ನಾವು ಉಪಯೋಗಿಸ್ತೀವಿ. ಸೊ ದೀಸ್ ಆರ್ ದಿ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ಕಾಮನ್ ಕಲೆಕ್ಟರ್ ಕಾನ್ಫಿಗರೇಷನ್. ಸೊ ಅಮಾಂಗ್ 3 configurations, that is common base, common emitter and common collector configuration, common emitter configuration is most widely used because they provide both current gain as well as voltage gain. Now let's derive a relationship, one expression to relate alpha and beta. We know that what is alpha? Alpha is the current amplification factor of common base configuration, whereas beta is the current amplification factor for common emitter configuration. And we know the expression for alpha and beta, right? Alpha is given by delta IC divided by delta IE, that is, it is given by output current to the input current. In common base configuration, IC is the output current and IE, that is the emitter current, is the input current. Let's call this equation number 1. Similarly, we have the equation for beta as well. In beta, it is the current amplification factor for common emitter configuration. In common emitter configuration, collector current is the output current, whereas base current is the input current. So let's call this equation number 2. We also know this expression, that is IE is equal to IB plus IC. So this expression is replaced by delta IE, delta IB and delta IC. So delta is the term which indicates change in current. So current ಬದಲಾವಣೆಗಳನ್ನ ತೋರಿಸ್ತಾ ಇರುವಂತಹ factor. So this equation can be replaced by delta IE is equal to delta IB plus delta IC. From this equation, we can have an expression for delta IB. So delta IB is given by delta IE minus delta IC. So ಈ IB value na, delta IB value na, let's replace it for delta IB in equation number 2. So substituting the value of delta IB in equation 2, what do we get? We get this equation. Beta is equal to delta IC divided by delta IE minus delta IC. So let's divide both the numerator and denominator by delta IE. So let's divide both numerator and denominator by delta IE. So we have this equation delta IC by delta IE divided by delta IE by delta IE minus delta IC divided by delta IE. So delta IE cancel each other. So we are left with 1. And what is delta IC by delta IE? It is the current amplification factor I alpha. So delta IC by delta IE andre it is the current amplification factor alpha. Hence we have an expression for beta as alpha divided by 1 minus alpha. It can also be expressed in terms of alpha. See, we have an equation for alpha here, right? Alpha is equal to delta IC divided by delta IE. Illi delta IE jagadalli you substitute this equation. Delta IE is equal to delta IB plus delta IC. When you substitute this equation, here we get this equation. Alpha is equal to beta divided by 1 plus beta. So, ನೀವು ಆಲ್ಫಾ ಮತ್ತೆ ಬೀಟಾ ಮಧ್ಯೆ ರಿಲೇಶನ್ಶಿಪ್ ಅನ್ನ ನೀವು ಬೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆಲ್ಫಾ ಬೈ 1 ಮೈನಸ್ ಆಲ್ಫಾ ಅಂತನಾರು ಇಡಬಹುದು ಅಥವಾ ಆಲ್ಫಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ಬೀಟಾ ಡಿವೈಡೆಡ್ ಬೈ 1 ಪ್ಲಸ್ ಬೀಟಾ ಅಂತನಾರು ಇಡಬಹುದು. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ರಿಲೇಶನ್ಶಿಪ್ ಅಥವಾ ಈಕ್ವೇಶನ್ showing the relationship between alpha and beta, where alpha is the current amplification factor for common base configuration and beta is the current amplification factor for common emitter configuration. So in this session, what we have learnt? We have learnt about 3 different configurations. What are the 3 different configurations? Transistor configurations: common emitter, common base and common collector. In common emitter configuration, emitter terminal is made common for both input as well as output circuits. In common base terminal is made common both to input as well as output. In common collector configuration, collector is made common to both input as well as output sections. We also learnt about their applications. So idರಲ್ಲಿ ನಮಗೆ ಏನು ಗೊತ್ತಾಗಿದೆ? Common emitter configuration is widely used because of various reasons. So it provides both current gain as well as voltage gain. And also we have understood the concept of current amplification factors alpha and beta. Current amplification factor alpha, it is for the common base configuration. Similarly, beta is the current amplification factor for the common emitter configuration. And also we have derived an expression to show the relationship between alpha and beta. So that's all we have for this session today. So let us summarize the session with the help of these multi-choice questions. So the first question is, the value of alpha of a transistor is. So alpha du value ಏನಂತ ನಾನು ಹೇಳಿದೆ? Alpha ಅಂದ್ರೇನು? It is the current amplification factor for common base transistor, common base configuration. So all current amplification factor andre it is nothing but the ratio of output current to the input current. In case of common base configuration, output current is collector current and input current is emitter current, and both the currents are almost equal, and hence the value of alpha is, let's look into the options, more than 1, less than 1, it is 1 and none of the above. So it is less than 1. Current amplification factor alpha, it is nothing but delta IC by delta IE. So it is always less than 1. Let's look into the second question. In a transistor, IC, that is collector current, is equal to 100 milliamperes and emitter current is equal to 100.5 milliamperes. The value of beta is. So ಇದು problematic. ಒಂದು ಪೇಪರ್ ಪೆನ್ ಪಕ್ಕದಲ್ಲೇ ಇದ್ರೆ ತಗೊಳ್ಳಿ, ಸಾಲ್ವ್ ಮಾಡೋದಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ. ಬೀಟಾ ಅಂದ್ರೆ ಏನು? ಬೀಟಾ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಔಟ್ಪುಟ್ ಕರೆಂಟ್ ಬೈ input current. So beta is the current amplification factor for common emitter configuration. Common emitter configuration nalli output current ಯಾವುದು IC, input current ಯಾವುದು IB. ಇಲ್ಲಿ IC ವ್ಯಾಲ್ಯೂ ನ ಕೊಟ್ಟಿದ್ದಾರೆ as 100 milliamperes but IB ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿಲ್ಲ. So first we have to calculate the base current. Base current ಅನ್ನು ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು? From the given collector current and the emitter current, we can definitely calculate the value of IB because we have the expression IE is equal to IB plus IC. So IE value nu gottide, IC value nu gottide. So we can easily find out the value of base current. So IB is equal to IE minus IC because IE is equal to IB plus IC. Hence IB is equal to IE minus IC. IE is equal to 100.5 milliamperes and IC is equal to 100 milliamperes. Therefore IB is equal to, which is IE minus IC, is equal to 0.5 milliamperes. So the base current value is equal to 0.5 milliamperes. Now the value of beta can be easily found. Beta the formula eno, expression eno, it is nothing but IC divided by IB. IC andre eno 100 milliamperes. IB andre eshtu? Just now we found IB to be 0.5 milliamperes. So beta is equal to 100 milliamperes divided by 0.5 milliamperes. So eshtu bantu? Let's look into the options. Option A is 100. Option B is 50. Option C is about 1. Option D is 200. So 100 milliamperes divided by 0.5 milliamperes. So the answer is 200. Option D is the right answer. So the next question is the relation between beta and alpha is. ಈಗ ತಾನೇ ನಾವು ಆ ರಿಲೇಶನ್ಶಿಪ್ ನ ಡಿರೈವ್ ಮಾಡಿದೀವಿ. So let's look into the options. Beta is equal to 1 divided by 1 minus alpha. Second option is beta is equal to 1 minus alpha by alpha. Third option is beta is equal to alpha by 1 minus alpha. Option D is equal to beta is equal to alpha divided by 1 plus alpha. So which is the right answer? We know that option C, that is beta is equal to alpha divided by 1 minus alpha is the right answer. The next question is fourth one. The voltage gain in a transistor connected in dash arrangement is the highest. So which arrangement will give you the highest voltage gain? Let's look into the option. Common base, common collector, common emitter and none of the above. So the common emitter configuration gives you the highest voltage gain. ಇರೋ ಮೂರು ಕಾನ್ಫಿಗರೇಷನ್ ನಲ್ಲಿ ಯಾವ್ಯಾವುದು? ಕಾಮನ್ ಬೇಸ್, ಕಾಮನ್ ಕಲೆಕ್ಟರ್ ಮತ್ತೆ ಕಾಮನ್ ಎಮಿಟರ್. ಈ ಮೂರು ಕಾನ್ಫಿಗರೇಷನ್ ನಲ್ಲಿ ಕಾಮನ್ ಎಮಿಟರ್ ಕಾನ್ಫಿಗರೇಷನ್ ವಿಲ್ ಗಿವ್ ಯು ಹೈಯೆಸ್ಟ್ ವೋಲ್ಟೇಜ್ ಗೇನ್. The fifth question is the configuration which provides both high voltage gain and high current gain. ನಮಗೆ ಗೊತ್ತೇ ಇದೆ ಕಾಮನ್ ಬೇಸ್ ಕಾನ್ಫಿಗರೇಷನ್, it provides voltage gain but lesser current gain. Common collector configuration, it gives current gain but lesser voltage gain. But common emitter configuration, it provides both voltage gain as well as current gain. So let's look into the option. Option A is common base, option B is common emitter, option C is common collector. So we know that common emitter is the configuration which provides both voltage gain and current gain. Bari ashte alla, sufficiently high voltage gain and high current gain anna provide ಮಾಡ್ತಾ ಇದೆ. So this is the end of the session. In this session what we have learned? We have learned three different configurations of transistors. ಅಂದ್ರೆ ಯಾವ ಥರದಲ್ಲಿ ನಾವು ಟ್ರಾನ್ಸಿಸ್ಟರ್ ನ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಬಹುದು ಅಂತ ಆ ಮೂರು ಕಾನ್ಫಿಗರೇಷನ್ದು ಅಪ್ಲಿಕೇಶನ್ಸ್ ಏನು, ಎಲ್ಲೆಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಓದಿದ್ವಿ. ಕರೆಂಟ್ ಆಂಪ್ಲಿಫಿಕೇಶನ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಬಗ್ಗೆ ಓದಿದ್ವಿ, ದಟ್ ಇಸ್ ಆಲ್ಫಾ, ಬೀಟಾ ಅಂಡ್ ಗಾಮಾ. ಆಲ್ಸೋ ವಿ ಡಿರೈವ್ಡ್ ಅನ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ for the relationship between alpha and beta. So that's all we have in this session for today. Thank you so much.